model the image of the triangle after translation. So translations left, right, up, down along x minus 2, y plus 9. So since it's minus, you're technically going left 2 and you're going up 9. Now the problem with the picture that they gave us is if you notice the graph is actually counting by 2. So it goes 2, 4, 6, 8. So you can either carefully use the graph, but also plus 9, like you're not going to really be able to go that high up. So I would just use the coordinates and do the math. You don't even have to use every single coordinate point. If I take M is at -3, 7, and I use the math rule. If I minus 2 to x, so I'll kind of do it underneath it, I guess. If I use the rule, minus 2, and then I'm going to add 9 to y, where would it end up? -3. Bye, thank you. -3 minus 2 ends up at -5. 7 plus 9 ends up making 16. So even if you just look at M, you could tell that A would be your answer. If you want to double check another coordinate point, you can. So I'll use P to do that. But it's like, I don't have a box. And also it's to my like flash drive, so it's only this long. Or you could technically plug it in your computer and let it charge. But you know what I mean?
Yeah.
It's a Type-C charger.
Oh,
Oh, you need the iPhone charger.
yeah.
Oh yeah, that's fine. Charger.
Do you have the new iPhone or
I have the new one.
with the USB-C?
Yeah, I think. I don't even know. Yeah, I have like
Yeah.
a C charger.
Yeah, I don't have
You need like an iPhone charger. My bad.
You alright?
Oh, I'm sorry. I'm about your loss.
My phone's dead. Ugh.
Do you have soccer practice today?
No, we have 3 games at 8 p.m. this week. What? I know.
Yeah, that sucks.
Just gonna go never sleep basically.
It's gonna be fine.
It's okay though.
Okay, I'm filming a YouTube video.
Sorry.
Okay. Okay, bye. P is at 2, 6. So if I minus 2, for example, if I minus 2 and I add 9, P prime is going to end up at 0. And what is that? 15? Yeah. So you could always check 2 points if you really want to make sure you're careful. But P and M are both correct. If you want to check them all, you can check them all. But you don't need to. So for number 2, 2 says, what are the coordinates of P? Where the coordinates of P are 6, -2. I'm going counterclockwise 90 degrees. So the rule for that is -y x. So I'm doing 2 things. I have to flip the coordinates. So it becomes -2, 6. And I need to change the symbol in the front. So when I change the symbol in the front, it was negative. I'm making it negative. 2 negatives make a positive. So it's actually 2, 6. For number 3, this is one of the harder problems. It's a 2-step problem. It says which series of transformations will map triangle DEF onto D prime, E prime, F prime. So they give us the original and we're going here to the new one because the new one has the primes. So for this, once again, you could check every single point. I'm just going to use 1 point. So I'm going to focus on E. I basically need to figure out which one of these will take me to E prime. So if I start by just writing out E, E is at 1, 2. And then I'm going to test each rule. So if this is where I start, I'm going to start by going 90 degrees counterclockwise. My rule is -y x. So I'm going to use a pencil so I can erase this. So if I flip it and I make the front negative, E turns into -2, 1. So if I think about this, -2, 1, -2, +1. That's where I'm at. The second part says a reflection over the x-axis. So if I reflect across the x-axis, this is the x. If I reflect across the x, they're saying E prime in the end will end up right here. That is not down here. So A does not work. So I'm going to have to do something else. So A is out. I'm going to try B. So I'm going to use the same coordinate and I'm going to figure out where I'm at. So first thing is a translation along -3, 2. So I'm going left 3. I'm going up 2. So I'm going to focus on E still. So I go -3, 1, 2, 3, and up 2, 1, 2. I end up here. Then followed by a reflection over the y-axis. So if I take my point and I reflect across the y-axis, I'm 2 to the left, so I'm 2 to the right. That is not down here. So that's not going to work. So B though. Let's do C. C says I'm going to translate left 2 or left 3, up 2. So 1, 2, 3, up 2. So I still end up here. This time I'm reflecting across the x-axis. So we count the distance from the x-axis. So I go 1, 2, 3, 4 above the x. So now I'm going 1, 2, 3, 4. That took me to E prime. So that is the correct answer. If you check the last one, it will not work. If it was my test, I would check them all. So I'll show you. If I go 90 degrees counterclockwise, that would change the coordinate to 90 degrees is -yx. So that would change to -2, 1. And then if I reflect across the y-axis, I would end up over here. So that does not work. So C is the answer. For number 4, we need to, it's really a vocabulary question. So 4 says, identify each transformation that would preserve distance when applied to the pre-image. Distance stays the same for translations, reflections, and rotations. The one that does not preserve distance is dilations. Somebody's knocking. Okay.
So we are in talks with the current settings county for permits.
Still,
And
yeah. But I think
that's
last
pretty
time,
good. What?
I think last time you were still doing that.
Oh, yeah. We're still doing that because we don't have any, I'm going today to pick up the first sponsorship.
Okay.
So that's exciting. And we have 2 sponsorships that we're gonna pick up this week. Which hopefully should get us over what we need for getting the permit, which is probably gonna be between $400 and $500.
Yeah, I was gonna say that's a couple $100.
And putting it online.
Yeah.
So hopefully by the end of Thanksgiving break, we're gonna have it online.
Okay, good.
So,
Yeah, because it's in like 2 months.
yeah, I'm like stressing about it.
Yeah, that's a lot.
Yeah.
Okay, good.
You wanna see some bird photos?
Yeah, I'll see some bird photos real quick.
I just had a history test.
Oh my gosh, he's so beautiful.
Isn't he great? We went and saw it because we had a cross country meet, like a couple of weekends ago. Yeah. And it was down in Fort Myers and they live down there, so.
Oh my gosh, that's so cool.
I know, I was so excited.
Aw.
What's this?
Oh my goodness, what kind of bird is that?
That's an osprey.
It looks extra fluffy.
And then,
Usually they don't look like that.
yep, and well, he was looking at me at like a weird angle.
Yeah.
And then you're like this.
Oh my goodness, so cute.
This one is named because it has a band on it, so we could actually tell which
Oh,
one
wow.
individual it was.
Yeah.
This one's named Outback.
That's cute. That's cool.
Mhm.
That's fun. Okay,
Cool.
thanks for stopping by and giving me updates.
You're doing great.
I'm excited. I'm not doing much, but you're doing great. You're doing amazing.
All you need to do is So that we did it.
Yeah. And you're like, heck yeah. Bye. Okay. So it does not preserve, when it does not preserve distance, that's a dilation. So everything but a dilation keeps the distance exactly the same. So the same size. Dilations will make a square big and then it make a square small. Okay. All the other stuff, reflections, keep it the same size, exactly the same. Clockwise rotations, just spin it. So it's the same shape, same, that's that, whatever. Okay. So it's A, C, E, and F. Same shape, same size. Dilations change, so it does not preserve distance. 5 says that we are plotting our points and then we're rotating around a specific point. So if I plot my points in -2, 4, here's A, B is at 1, 3, C is at 2, -3, D is at -3, -1. So if I make my quadrilateral, it says it is rotating about B. That's the key word. B is where I'm going to draw in my X and Y axis. So when we did this, we used a colored pencil and we colored it in. So that way we could spin around a point. This is another one. I would not change all of the shapes or all the coordinates. I only care about C. If you think about this, it's rotating 90 degrees counterclockwise. So it's spinning this way. C is moving 1 quadrant, so it's going to be somewhere up here. C, B is technically the new 0, 0. C is 1, 1, 2, 3, 4, 5, 6. C is 1, -6. If I use 90 degrees counterclockwise, that is -y, x. So if I flip it, I change the front. It was -6, so now it's +6. So if I go over 6, 1, 2, 3, 4, 5, 6, and up 1, I end up right here. That is in quadrant 1 of the graph, because there's a 1 here. So for number 6, it gives you the image and the pre-image. The pre-image does not have the little dashes. So this is where I'm starting, and I'm going to the prime, A prime, B prime, C prime. So this is where I'm going. So if I look at one coordinate, I'm going to the right and I'm going down. So 1, 2, 3, 4, 5, 6 to the right, down 1, 2, 3. So 6 right, down 3. 7 is a play on words and vocabulary. So it's a little, I think this is the most confusing on the test. It says the transformations given are performed on pentagon ABCD to create A prime, B prime, C prime, D prime, E prime. The first transformation is a translation. This is right 5, down 6, but there's also the multiplication. Because there's a 2 with the X, that is a dilation. It's also a translation. The second step says counterclockwise rotation. So the second one is a rotation only. Says complete the sentence to explain whether or not the pentagons are congruent. So they are not congruent. The reason why is because the dilation changes the size of the shape. So they're not the same because one's going to be big and one's going to be small because of the dilation. And it wants to know, this is the part that's really confusing. It says, because both of them each, neither of them, or only the second transformation preserves sides and angle measures. So you have to think, do both of these or neither of these or only the second preserve sides and angle measures? The first one is a dilation. It does not preserve length. The second one is a rotation. It does preserve length. So it's only the second that preserves length and angle measures. 8 says in the graph, we're going to fill in vector notation. So we are starting, the key for this one is it's starting at DEF and we are going to PQR. So DEF is here. I'm going to PQR, which is here. So if I match up my letters, I'm going to look at E because E is kind of out in the open, and so is Q. So I had to go to the left and I had to go up. So if I go to the left, I have to go 1, 2, 3, 4, 5. I had to go left 5. And I had to go up 1, 2, 3. So this, since it's left, that first notation is going to be -5. Up 3 is +3. You are not putting the x in front. X -5, y +3. That is algebraic notation. This one's vector, so you just put the numbers, not the x or the y. For number 9, 9 says it's 2 steps. It's rotated 90 degrees counterclockwise about point A. So if I draw my x and y axis at point A, here's x, here's y, A becomes 0, 0. B is at 2, 1. And C is at 1, 1, 2, 3. 1, 3. I'm going to rotate it 90 degrees counterclockwise. The rule for that is -yx. Now, this is another thing. It technically just says point C. We only care about C. So you don't have to do all the other ones. You only care about C. So I'm going to move C only. If I flip it and I change the front, that becomes -3, 1. So if I plot that on my point, my graph, -3, 1, 2, 3, up 1. So C's here now. Then I have to translate 1, -4. So I'm going to go right 1 because it's positive, down 4. Right 1, down 4. 1, 2, 3, 4. So the final answer ends up here. We need to figure out where that is on the real graph. So when you're going back, you need to figure it out on the real x and the real y axis. So back to 0, 0, -1, -2. And then 10 says triangle XYZ is transformed to create X prime, Y prime, Z prime using the rule X plus something, Y plus something. So this is algebraic notation. We basically need to figure out what values go in here and here because these are typically numbers. So triangle XYZ has these vertices. X prime, Y prime, Z prime has these vertices. So you don't need to look at all the points. I'm going to look at the first ones. That's X and that's X prime. So if I think about the numbers, if I got 3 to change to -1, I'm getting smaller. So I'm actually minusing something to my X. So 3 to -1, you have to minus 4. So B is -4 because you're subtracting 4. So adding a negative is the same as subtracting. If I look at the Y values, I have -2 to +6. So I'm getting bigger. So it's adding some number. So -2 plus 8 will get me to 6. So this is positive. So I just need the 8. I already have the plus sign. This one I'm adding a negative because it's subtracting. So that one has to be negative because it's getting smaller.